Welcome to our webinar, everyone. My name is Kel Lupus. I'm a co-convener of the Sydney branch of Renew. And a little bit about who we are. Renew was established in 1980 as a national not-for-profit organisation to inspire, enable and advocate for people to live sustainably in their homes and communities. Welcome to you all, even if you're signing in locally from the Sydney region, elsewhere in Australia, or maybe even from overseas. It's always exciting to be engaged with so many people. Firstly, I want to acknowledge the traditional owners of the land upon which the Sydney branch operates and where I am at the moment, the Bidjigal clan of the Eora Nation. We acknowledge their leaders past, present and emerging, and we also acknowledge their sustainable stewardship of the country over many millennia. I'd also like to acknowledge the traditional leaders of other parts of the country or in other lands, wherever you may be. Perhaps you'd like to let us know in the chat box where you're joining us from. Tonight we have a busy schedule with some great speakers, but I'll leave it to my co-convener, Stephen McCulloch, to introduce them individually. But before we start, just some housekeeping. If you have technical issues during the evening, please use the chat function to get assistance. You can ask questions using the Q&A button. We'll go through some questions after the second presentation, and it's normal to get more questions than we have time for, so please be patient. We will be recording the presentation, and that should be available on our YouTube channel in the coming weeks. Now, over to you, Stephen.
Good evening, everyone, and thank you for joining us for tonight's Renew Sydney Central Branch seminar on home battery storage and energy independence. It's heartening to see so much interest in the future of energy, particularly the role home batteries and electric vehicles play in helping households reduce power bills and emissions. Here in Australia, we're at a pivotal moment with battery prices becoming more competitive and technology more advanced. The barriers to entry are lower than ever. Federal and state government incentives, including the 30% rebate scheme, are making it easier for homeowners to take control of their energy use, reduce reliance on the grid, and prepare for a more resilient future. With regards to the federal rebate scheme, it seems perhaps unsurprisingly, it is proving very successful. In a LinkedIn post I saw earlier today by Chris Bowen, he claimed that already since the 1st of July, 16,304 households have taken advantage of this grant. That amounts to about 280 megawatt hours of battery storage. But opportunity brings complexity. There are now many options, from solar-coupled battery systems to using your EV at home as a power source. The array of technologies, tariffs, regulations, and integration of pathways can be overwhelming for anyone trying to make an informed decision. Tonight is about clarity. Our aim is to demystify those choices and to provide insights into how home batteries and EVs can work together to deliver both savings and stability. Whether you're looking to invest soon or simply want to understand the shifting energy landscape, this session is designed to inform and empower. Let's dive into what is possible and how households across Australia are leading the charge into smarter, cleaner energy future. To present and discuss batteries for home, we have two excellent speakers, both experts in this arena. I will introduce them individually, but please note we have a Q&A session once both speakers have presented. First up is Avinesh Naidu from Kean, who will speak to the topic home batteries, smarter storage, greater independence. Avinesh is a consultant specializing in solar energy with deep industry knowledge and technical expertise. He has over a decade of experience in designing, engineering, and project and contract management, and the deployment of renewable energy assets. Over to you, Avinesh.
Yeah, thanks, Stephen, for the lovely introduction. My name is Avinesh, and I represent Kean Energy. Next slide, please. What we do, I've got 26 years of experience in the solar industry, looking at residential, commercial, and industrial solar and battery applications. We are the owners, engineers, and all we do is provide advice to various customers with regards to products, design, quality, and most important, performance. Next slide. Well, solar battery is a big topic right now. Just about everyone has been bombarded by emails, phone call, SMSs about solar battery for their residential property, and there's a lot of noise out there with lots of price point and so forth. So it's important to understand, what is this product about, what's the rebate that's out there, and what's your checklist? What are you exactly wanting to know before you make the decision? As we may all know, solar is made up of three main components now: solar panel that goes on the roof, a solar inverter that sits near the meter box that converts sunlight electricity into usable electricity, and then the addition of batteries, which is there to store energy and obviously supply during higher tariffs and so forth. Now, the first thing is always about safety. In Australia right now, Clean Energy Council lists 113 brands of batteries that's available, for sale. Now, that's a lot, and this number will be increasing, to much more in the near future. How do we differentiate between good and bad and poor quality batteries? Obviously, there is a difference. The minimum standard that all batteries comply with is an Australian standard, which is similar to a IEC standard, which is 62619. It is a safety standard that looks into charging, discharging, and protection of batteries, obviously from a electrical point of view and also from a fire safety point of view. The most common chemistry that's used with solar batteries for residential and commercial application is lithium iron phosphate. There's other chemistries available, but this is the most popular and most common one that's used. There's two setup that's available with batteries. The first one is a ground-mounted stackable setup. Basically, as in the photo, the battery sits on the ground, and it's a modular system sort of built ground up, similar to a Lego setup. This has got a lot of flexibility. In the photo there, this battery is made up of 6 stacks. We can get 3 kilowatt hours all the way to 12 kilowatt hours of per stack module. And basically, once the system is installed, there is flexibility to add more modules in the future based on your usage. So, in a way, it gives you that, flexibility to add on in the future. The second common battery setup is wall-mounted, and Tesla is a good example. There's a few others that's available. Sometimes the residential customers don't have enough space around the house for a ground mount system, so a wall system is another option. The key difference is that with this system, it's not that modular. So if you want to add a second system, it's the whole second system that needs to be added. The flexibility part is limited, but it saves a lot of space of not using the ground area. In terms of battery specification, it is very important to note there's a rated kilowatt hour versus usable kilowatt hours. So all batteries are rated with the term kilowatt hours. And there's a difference between what the battery is rated and what you can use out of it. So it's very important that during this sales process, you get to understand, from the proposal, what are you exactly getting. The battery capacity decreases over the years. There's a degradation of around 1%. And this is key because what you're buying today and what is being installed today, what are you gaining out of this battery in year 5 or in year 10? And it's very important that as a customer, you read through the product warranty in terms of what are the warranty that's provided, with regards to the capacity of the battery. I've just shared a small screenshot of a battery that shows the two different numbers. A lot of times usable is 90 to 95% of the rated capacity. So it's very important to understand that. A lot of times when you get quotations, the term that's used in the sales pitch is rated capacity. So you have to be careful. Now, this is the key thing. One of the key difference between qualities of battery is when you get the battery on day one of install, say it's rated at 20 kilowatt hours. You have to be very clear that whether that's a usable or rated capacity. Lots of higher quality battery actually is specified to a higher rating, say 23 or 25 kilowatt hours. So they present their rated to be same as usable because they compensate for the losses of the next 10 years on day one. So you're buying a 20 kilowatt hour battery, but actually it is a higher rated battery. And that's the key difference, because then you look at some other batteries, which is cheaper and a bit lower in quality. But you buy that battery at a 20 kilowatt hour rating, but then year 5, it will be less because they haven't compensated for the losses. So that's a key difference that one needs to note. Currently, we've got the federal rebate that started July 1st, and it has been very popular. Some of the key aspects of the rebate is, the rebate is around $370 per kilowatt hour usable. For example, if you're buying a 10 kilowatt hour battery, you will get somewhere around $3,500 to $3,700 of discount. With the 20 kilowatt hours, it's a $7,000 rebate. On average, after the rebate, the customer would be paying out of pocket somewhere around $5,000 to $12,000 for a 20 kilowatt hour battery, which is a very common size that's currently used in the marketplace, just to sort of have a gauge of where the price points are. Battery prices vary due to many things. Obviously there is the battery quality aspect, and this comes by due to various manufacturing processes, how big or how large is the manufacturer, and what are the tests that's done on the battery to ensure the safety of the battery and durability of the battery. You're buying something that is lasting 10 years minimum based on the warranty that's provided, but it can go on to 12, 15 years. Installation is another key part of the cost. It's very important that when you buy a system, the expectation isn't that you get a quotation with a price that you've sort of signed off by the deposit. Next, someone rocks up at your house at 7 in the morning with a battery ready to install. Now, that's not the best approach. You should be very clear that once you purchase, there should be some communication from the company selling you the battery, that they have the installer visit your property well before the installation date, scope out where the battery is to be installed, how we're running the cables from the battery to the meter box, the aesthetics part, the safety part. Are you happy with the location of the battery? They will do the measurement in terms of making sure that there's clearances from the existing services such as water heaters and so forth to the battery location. There's all these things that needs to be scoped out. A lot of times what happens is installers are trying to do 2 systems in a day. The battery came in at a cheap price, and one also needs to understand that there's 3 parts to this. One is a battery manufacturer who manufactured the battery. The second is the company that you're purchasing the battery from, who is like a middleman. And then the third is the installer that's installing the battery, who are most likely subcontracted by the company that you purchase the battery from. So everyone has got their part to play. It's very important that that part is covered, from a site visit point of view. And that's a cost. And a lot of companies don't do that, and that cost is not reflected in the battery prices. Performance and safety testing, and that's the difference between smaller manufacturers and larger manufacturers in terms of making sure that their battery perform, to the warranty that they are providing. The other key thing is features of the battery. One good example is monitoring. You've got a battery which is supplying, and the whole point of having a battery is to essentially zero out on your electricity bill. You need very good monitoring system to ensure that you've got your eyes on the performance of the solar and the battery every day, and the end of month data reflects on your electricity bill. So, you need a good level of monitoring, and that's part of a good battery. After sales service, this is very important. You're buying something that will last 10, 15 years. You want to buy it from a company that will be there to support, any failures with the battery technically. So it's very important that you do a few checks, before, committing to buying a battery with the sales company. Performance guarantee. Now, this is not a very common term used, especially with the residential systems, but you are buying a system that needs to perform. The company that's selling the system needs to display and present you how will they maintain the performance of your system. This is not a black box that you're just buying, that they are just installing and that's it. There needs to be regular checks in terms of how the battery is performing and what are the things the company is doing to ensure that the battery is performing. The other key part is the battery life. All batteries comes with the number of cycles. The idea is that if it's one cycle a day and it's 3,650 cycles that the battery can present, then that's 10 years. So, what you'll see is that different battery prices comes with different types of battery, and each has got a different number of cycles. And these are, look, it's a bit more technical, but I thought I'll just share that with you guys. So, there is, further, reading that can be done. And then the last thing is just undersizing. The idea is to sell the biggest battery system. And, I've seen proposals where a 40 or 50 kilowatt hour battery has been sold with just a 5 kilowatt inverter, because these are all costs that, they're finding ways to reduce. So what I've done is, I've sort of stepped into the shoes of a customer and just prepared a few checklists. And the idea is that these are questions that the customer should ask the energy retailer or the company that's providing you with a battery quotation. And it's very important that these things are captured in the proposal so that it's written down. It's very important. The first thing is, simple, you're buying a battery that needs to be charged with cheap energy, and that's from solar and in some cases off-peak power. Is there enough solar export that's available at your property to charge the battery? The company needs to demonstrate a table or data that supports this, and this needs to be verified. What is the estimated solar output every month, that's available to charge the battery? What you don't want is, you've got a solar system and, you're only exporting 10 units a day on average, say in winter, and you bought a battery that's like 40 kilowatt hours, then you are not sort of optimizing the use of the battery. Optimizers is another key thing in terms of, what you require. A lot of households on average, they use 20 to 30 units a day. And that's why 20 kilowatts seems to be a very common battery size. But, end of the day, you need to be very clear in terms of what your needs are right now, forecast what your needs are in the future, and, understand that that's important rather than just buying a battery just for the sake of, a rebate that's available. The other key thing is with the installation. A battery is a fire hazard. Everyone knows that. It's a very small box with a lot of energy, and any impact can lead to really bad situations. If the battery is installed in an area where there's traffic, say in the garage, then one needs to ensure that there's, for example, fire alarms, there's bollards, there's ways of protecting the battery. And this is very important, in terms of when looking at the location of the batteries. And that's where the initial site visit by your, the company is very important, because you need to be very clear. It should be well documented in a drawing form exactly where the battery is going and the whole action plan for the installation. Now, power failure is something that's not very common right now, but is something that does happen. You need to understand how is the battery providing backup to your existing load. In some cases where you've got existing solar and inverter system, the battery is just an add-on to that system. You need to know that the battery, if it has got a backup circuit, it can provide to some circuits or some loads in your household. But if the battery runs dry of energy, solar is not connected directly to the battery, so there's no more energy supply, because solar will turn off with any grid failure. So you need to get that information from the company in terms of exactly how the system will perform during a grid failure, and what loads can be connected and so forth. And as the next point, in terms of like with the current setup that you will have, whether solar will work during power failure. There needs to be very clear written instructions given to you in terms of how the battery can be replaced under warranty. You need phone numbers, addresses, turnaround times, and even an understanding of if there's any cost compensation, if there's any delay with battery replacement, or if you need to obviously call in an electrician, and what costs are covered, because larger battery companies do provide a lot of this information and do provide a lot of support, because they stand by the product, which is a very low failure product. And the other key thing is when you're talking to the company that has provided you with the quotation, talk the bigger picture. If my battery fails, what's your reaction time? What's your turnaround time with coming back, replacing it? Now we've had many cases where it takes 2 months or 3 months for the battery to be replaced, because it took them 3 weeks to detect a problem, and then took another 3 weeks for electrician to visit the site and so forth. And that doesn't represent a good solar company that you're dealing with. And it's very important to sort of get these things cleared. Same things in terms of a segue, in terms of you dealing with a company and the battery stops. How are they sort of providing that performance warranty? What are they doing from then to ensure that the battery has stopped, and they are reacting, rather than you kind of telling them that the battery stopped working. One needs to understand, okay, I've got a battery, but you need to help me understand how will I be using my battery optimally. What are the best times to use the battery, and provide that communication. So it's an ongoing thing. It's not a an installation and forget about the system. You also need to demand a quarterly report from these companies, in terms of battery performance, so that there is a ongoing, communication and engagement. You need to demand a sample single line diagram, so that you're committing these companies to ensure that when the battery is installed, you get a single line diagram that's kept. And these things are important, because then you're sort of committing these companies in terms of taking action, and not just become a company that's selling you something and then forgetting about it. These are some basic things that you always need to do, and it's a very common problem within our industry. Always check how long this company has been operating, the ABN numbers, and so forth. We've got a very common thing of companies selling solar and batteries after 2-3 years with volume sale, all they've got is liability with warranties. And what they do is they change company names, change ABNs, and restart a new company. So they don't have any responsibility with anything they've sold previously. And like someone can write a book on that. But that's the reality. So you need to sort of read your checks, I have to reiterate again that we are talking about something that will sit in your property for 10-15 years, and that will ensure that you pay the lowest electricity bill possible, and it needs to work. So it's a long-term investment. Also with the manufacturer, like do some research in terms of how big is this battery manufacturer. We're talking about battery manufacturers that's a $10 billion company versus someone who's only $500 million and has been operating for the last 5 years, and suddenly with their local demand they've increased their production. So there needs to be some sort of a research done, and a great place to start is ChatGPT. All batteries right now, or most batteries, are manufactured in China. Do get documentation of the modern slavery and ESG reporting, as this demonstrates the company's commitment in terms of manufacturing good products that's acceptable. Yeah, so I must say it again, ensure that you get written answers to some of these questions in your proposal, and that shows that you're dealing with a company that's customizing a solution for you, customizing a service for you, and is there for the long run. Because good companies will answer your questions, will provide you with a much better value proposition. That's it for me. I try to sort of capture essentially questions that our audience would ask. If there's any other questions, you can always email me, or I'm always posting stuff on LinkedIn. Thank you.
Thank you, Avinesh. That was a very informative talk, and some very useful information. Our next speaker is Tim Eden, who will speak to the topic of batteries on wheels, your EV as a power source. Tim has spent most of his career as a network engineer and site reliability engineer, part of his claim to fame being that he helped to keep Google systems up and running for 14 years. He got hooked on electric vehicles during a work trip to the US in 2014, where he saw a glimpse of the future while driving a Tesla Model S. After leaving Google a few years ago, Tim has worked for Polestar Australia and now writes for the EV-focused The Driven website, where he enjoys sharing his knowledge and experience with others. Over to Tim.
So I won't go into too much more detail because Stephen already touched on the highlights of my career so far. But yeah, sort of going around in clockwise order, looking at these logos here. I studied computer science and worked at UNSW. That was my first job, supporting the university-wide network. As Stephen said, spent a long time at Google helping to keep that Google systems up and running, which was a great job. I love that. A few years ago, I followed my passion after getting hooked on EVs, as Stephen said, traveling to the US with Google. I did a trip over there back in 2014 and drove one of my bosses, very early Tesla Model S. And I couldn't believe he was letting me have a go of this expensive, shiny new electric car, but it was such a fun drive. It was so fun to drive, and I had a blast, and I was just hooked. Ever since then, I've just been, watching all the YouTube videos about EVs and learning as much as I could. So having been at Google for 14 years, it was probably time for a change anyway. And I realized towards the end of my career there that I was actually enjoying doing tech talks on things like solar power and the state of electric vehicles in Australia and things like that. So decided to follow my passion, joined the EV company Polestar, was there for about 18 months working on sales. And then a couple of years ago, as Stephen said, moved on to now working at The Driven, one of the regular contributors there. I also do some stuff on the back end, like maintaining the monthly EV sales data that we publish, as well as a list of all the EV models, prices, range, those kind of things. So today we're obviously talking about batteries on wheels as the title of the presentation. And first up, we'll just go through some terminology just to make sure everyone's on the same page. So you may have seen some of these terms around before. So you've got V2 and then a different letter. So they all stand for vehicle to something. and we'll go into each of these ones in a lot more detail, or at least in some detail on the following slides. So in this one, we're just talking about the names. So V2L, vehicle to load, vehicle to home, vehicle to grid, and vehicle to X, or vehicle to everything, some people call it. These general terms are also summarized as bidirectional charging, or BD or BIDI. I'm not sure how to pronounce that for short. So yeah. And when we say bidirectional charging, just to clarify, that's just saying it's unidirectional charging of an EV is obviously where you're taking power from the grid, charging your battery. Bidirectional obviously means you're taking power out of the battery and either using it in your house or grid, or as we'll go into. So vehicle to load, the first one of these scenarios is where you can essentially plug in any electrical load that you can think of into the car and use that car's battery, either via a standard 10 amp or 15 amp outlet. There's one major caveat there, which is you cannot plug in a house. So say you live in a house and you've got like some way to plug in your car into the house. Definitely don't do that, because that can risk damaging the house or the car. And yeah, there's definitely people who've done that and had issues. So definitely don't do that. But typical power output from a vehicle to load on a car is around 15 amps or 3.5 kilowatts. So that's quite a useful amount of power. You can do stuff, run a welder if you're out on a farm somewhere. This picture on the screen here is my brother. He lives out on a 1,200 acre off-grid property, and at that particular time in the photo, he didn't have any power in his shed, which is just in the background there. So I actually had a Kia EV9, which has vehicle to load in the boot, and he was making me a new fire pit out of an old beer keg. So he whipped out his angle grinder, plugged it into the car, was able to saw off the top, and yeah, about 10 minutes later, I had a shiny new fire pit, which I took home. So I've also used vehicle to load for just jobs around my house, doing things where it was right up at the top of my driveway. I wanted to install a new letterbox, and I think I had the EV9 or maybe a different car at that time, and I just plugged into the car and used my power drill there because I didn't have a decent cordless drill at the time. So a couple more things on vehicle to load. So most cars have settings that control how low the battery will go when you're using vehicle to load. So say if you're in a camping scenario, you may want to run fridges and things like that. Someone in the chat I see just mentioned fridges, but the car will typically go down to say 20% or 30% or whatever you set that setting to. So then you can always drive home and get somewhere without running your battery completely flat. There's also been some great stories of people using their vehicle to load feature during natural disasters. So like during the cyclone that was up on the East Coast earlier this year, people were using their vehicle to load on their cars to run things like dialysis machines or different things that are critical appliances that they needed to keep running and stay alive. So yeah, really good use cases of it, as well as having fun, like going camping and making fire pits. So there's two major sort of ways you can use vehicle to load, either an interior socket. So the EV9 on the previous slide has an interior socket in the boot, which you can use. In the picture on the left here, a guy's got his laptop plugged into an interior socket, which is in the back seat of the car. So that's something you'll see on a lot of cars. Sometimes it's in the front, sometimes it's in the boot. The other way you can do it is via some cars with vehicle to load support via an exterior adapter. So you can see in this case on the right hand side, you've got a vehicle to load adapter plugged into the charge port of a car. And then it presents a standard 10 or 15 amp outlet on there. So in this case, you can see a power cord dangling down there. So you can plug in, same as the interior socket, you can plug in any device into that. The third option, which is starting, I've seen some now, is where there's basically an aftermarket vehicle to load adapter, which can actually plug into, and this is not just for cars that support vehicle to load. So there's one, I've seen a guy on YouTube testing one on a Tesla, an old Tesla car, which doesn't actually support vehicle to load. But this is a box, a third-party external box, which you can plug in. It actually uses the DC pins of the car, and I'll go into AC versus DC in a couple of slides. But that basically essentially tricks the battery into exporting power via the DC pins, and then you can use that again to do whatever you want. So that's another option that is out there as well. You'll also see, as well as these two options, another sort of exterior option you're starting to see more is in the tray of utes. So things like the BYD Shark 6 has a couple of outlets in the boot, in the tray, sorry, at the back. So if you're a tradie and you want to take that on your job site and power your tools, that's a great way to do it. Otherwise, go camping and stuff like that. So the next sort of level up, I guess, if you want to talk about it, is vehicle to home, which is where you're essentially using the battery in your car to not just power any load, but in this case, you're powering all the appliances in your home, or at least some of the appliances. In this case, rather than just using the equipment built into the car, you actually need a dedicated bi-directional charger, as you can see in this picture. So what that does then is allow you to not only, I mean, it's very similar to a home battery in this case, in where you can store and use your excess solar energy. Although one thing you can't do with vehicle to home alone is export to the grid. So that's something we'll cover on the next slide. But vehicle to home, yeah, you can store and use your excess solar energy overnight, which reduces your reliance on the grid. It can also support your home during a power outage, which is an added bonus. Although it's perhaps not as useful if, say for example, you want to drive during that power outage, then you'll have to unplug your car and your fridge and other stuff will stop running. So potentially not as useful as a home battery in that case. One thing I just wanted to touch on here as well was battery life concerns. So that's something that I think people do sometimes worry about with vehicle to home or vehicle to grid. They're like, oh, is that going to destroy my battery and that kind of thing. So I would say there's more and more research coming out concluding that EV batteries are going to last much longer than initially thought. So I would say there's more and more research coming out which says you probably shouldn't have to worry about it. People are saying that car batteries will last 20 years or longer, and probably the rest of the car will fall apart before the battery stops working. So I personally don't worry about it. And just to illustrate with an example, like I have a Tesla Model 3 which is 6 years old. I've only driven about 80,000 kilometers so far in those 6 years, and so I don't think I have one of the batteries that's a million-mile battery, as Tesla was calling it at one point. So even though I don't have that battery, my battery is probably still going to be good for at least 500,000-600,000 kilometers, which is what I've seen on some other Teslas that have had battery replacements. So as you can see there's still a huge amount of life left in my battery, and I'm probably never going to get that point where it needs a battery replacement. So in that sense, I'm actually quite keen someday to get a vehicle to grid system and actually just make the most out of my vehicle battery, because I'm clearly not doing it by driving alone. And sort of the next step, and probably the last final step where we'll get is vehicle to grid. So this is essentially quite similar to vehicle to load, but in this case, you're also able to export power to the grid on top of just powering your own home. So in this case, it's pretty much exactly like a home battery, a stationary battery that Avinesh was talking about. So you can store and use or export your excess solar energy, supporting the grid during peak times, evening peaks, those kind of things. Another thing which I know Avinesh touched on some of the benefits of a home battery. And when he was talking about battery sizing, he was talking about making sure you have enough excess solar. I would actually add to that and say that with more and more, the coming out of retailers like Amber Energy, which give you access to the wholesale electricity market, you can probably worry about that a bit less, I would say, and actually, take advantage of very cheap, sometimes even negative power prices during the day, and actually charge up either your stationary battery or your big electric vehicle battery, and actually, charge it, be paid to charge it, or pay very little to charge it, and then send a whole heap, as much as you can, back to the grid during the evening peak, and potentially make, in some cases with the peak energy price, the wholesale price can go as high as $20 per kilowatt hour. So even if you can export, 5-10 kilowatt hours during that 1 to 2 hour window in an evening peak, when for example, a coal plant blows up somewhere, you can actually be making $100 to $200 in a single evening. So there's a lot of potential benefits there. Pros and cons versus a home battery. Given I've just talked about comparing to that, I would say you've got much more energy storage in an electric vehicle. So typical home batteries, again, as Avinesh was saying, probably about 20 kilowatt hours seems to be the norm. From what I've been reading recently, that average size is trending up more than expected with the battery rebate. So people are sort of going for 30 to 40 kilowatt hours maybe is becoming more common. But with an EV battery, probably the smallest sort of battery on the market these days in an EV is about 50 kilowatt hours. Some of them go as high as 100 or more kilowatt hours. So you can see you've got, even with a big home battery, stationary battery, you've potentially got 2 to 3 times the amount of storage in your electric vehicle. So much more potential to soak up that energy during the middle of the day when it's cheap or negative, and much more potential to export during the evening peaks and make more money. Sort of a con versus home battery is, obviously, I mentioned it with the vehicle to home section, but it only works when the car is home and plugged in, which is one potential challenge, I guess. I'm generally pretty good, and my wife is generally pretty good about plugging my car in to charge it. But in some cases, I'm using currently a retailer which gives me 3 hours of free energy during the day, and I obviously try and charge during that time. But occasionally, if the car's not plugged in, and I miss that window because it wasn't plugged in. So you've got that issue potentially with this setup as well. So maybe the best of both worlds in this case is a small home battery combined with vehicle to grid. So just touching briefly on vehicle to grid scale, just to give you some idea. So the CSIRO predicts we'll have about 8 million electric cars by 2035 on the roads, and with that vehicle to grid capability, able to export about 14 gigawatts of power. And that's roughly equivalent to about 7 times the output of Snowy 2.0 under construction at the moment. So, and that's sort of similar to the capacity predictions for where grid scale batteries will be at the same time. I think I haven't read what the prediction is for home scale batteries, but I'd say that's probably more research is coming out the same that people are going bigger and better for the home energy. So that's something to keep in mind. So next up, so when you're talking about vehicle to grid systems, there's 2 sort of main ways to do it: AC versus DC. So in this case, just to clarify those terms, so AC alternating current, DC direct current. Batteries store energy always in terms of direct current, so but your home and things uses alternating current or AC. So to get that battery energy out of the battery and utilize it in your home or send it back to the grid, you've got to do a conversion or an inversion from DC to AC. The difference between these two solutions here is where that conversion happens. So with AC, it's happening inside the car itself, essentially, using the car's onboard charger. So it's similar to when you're charging the car via a standard power point or any AC charging. The car actually takes the AC power, uses the onboard charger to turn that into DC to charge the battery. So with a bi-directional car, you're essentially reversing that process inside the car and then sending out AC from the car. The benefits is it's generally lower cost charging equipment. So the box you've got mounted on the wall probably has less stuff in it, less costly, but there's more complexity in the car and the software. And there's also less output power in that with AC as well. So typically you might only see 5, 6, 7 kilowatts. DC, on the other hand, is where basically you've got that inverter inside the charging equipment sitting on the wall, potentially in your garage or somewhere else. And so that's similar to solar systems where you may have solar panels on the roof sending DC power down, and then that inverter is sitting on the wall somewhere next to your meter box. Higher cost for the charger there, so there's obviously more stuff built into the charger, but it's less complex in the car, and it also potentially gives you more output power. So one of the brands that's doing a DC vehicle to grid charger, which is called SIG Energy, they actually have a 25 kilowatt module there. So that's a huge amount of power which you can charge and discharge your car. So finishing off, just to talk briefly about where we're at, because this is something that's obviously a lot of people are keen to use their battery and in their vehicle, and this is something that's been talked about for a long time. Where we're at now is we've had several trials have been conducted in the past using CHAdeMO, which is one of the 2 sort of main vehicle charging standards. CHAdeMO is the old standard, which most cars or no cars really use anymore, apart from existing Nissan Leafs, Mitsubishi Outlander, PHEVs, those kind of things. So a number of trials was done with those vehicles, and in some cases they were potentially generating a lot of revenue, as I was talking about before, not just from energy arbitrage, but also from supporting grids. So during the frequency control markets and those kind of things. Those trials were mainly done using one particular vehicle to grid charger, which was called the Wallbox Quasar 2. That cost about $10,000 at the time, and it's no longer on sale. So yeah, even if you have one of those cars, it's pretty hard to get that up and running again. Back in November last year, the government went out and updated AS 4777, which is the standard which deals with inverters in homes, and that now includes support for bidirectional chargers and vehicle to grid, which is great. And next steps, so basically now that those standards are approved, we're just basically waiting for Clean Energy Council needs to approve new vehicle to grid and vehicle to home chargers, just like they do for new battery systems before they qualify for the rebate. The distribution network service providers, or the people that run the poles and wires in the street, they need to allow vehicle to grid charging as well. Car manufacturers are also the sort of another piece in the puzzle, and they need to basically provide official warranty support for you to do this feature on their cars. So quite a few manufacturers have come out already and said we support this, but they haven't actually given us the official vehicle warranty and support and that kind of stuff. So the only one that's gone out and done that so far that I'm aware of is the Ford F-150 Lightning and the SIG Energy SIG Install battery. They're sort of approved for use, but only on certain DNSPs at the moment. So yeah, still very early days in this space. I would say if you're considering and you're really keen to do to get some battery storage in your house, then stationary batteries have been around for a long time, all well understood. Installers are familiar with them. You can go out and do that, and as I said before, export to the grid and potentially make money. Vehicle to grid is still quite early. Yeah, we're still in the process of approving things and getting things clear. So yeah, but that's where we're at the moment, and that's it for me. So I think we can. I'll hand back to Stephen and Kel, and then we can get into questions.
Thank you, Tim. That was very interesting and informative. So we've got a number of questions that come in on Q&A. You got a bit of applause there, notice, which is very deserved. I'll just go through these very quickly. And Kel, I think you can help me as well on this. Could you explain some more about the 6,000 cycles, 10-year warranty, battery wear, and battery sizing?
Yeah, I can take that question. So 10 years warranty is pretty standard right now with most of the batteries that's available. There's some batteries that offer a bit more, but 10 years seems to be a standard offering from the manufacturer. So basically that covers for defects and replacements and so forth. Number of cycles, every battery has got a standard term, which is number of cycles. If you look at the data sheet, if you assume that a cycle is basically a full charge and discharge, that's one cycle. And let's say if you assume that it's one cycle a day with the battery, then 6,000 divided by 365 days is the number of years that the battery has been designed from a operational point of view. So that's how the calculation is done. Some batteries they state it's unlimited cycles, but when you look at the battery warranty, it specifies they are only allowed to do one cycle a day. So there's these things that they sort of protect themselves from. In terms of battery wear and tear, batteries are normally a stationary object, especially with lithium. It just charges and discharges to a very low point. It's very different from the past lead acid batteries that we used to have in terms of maintenance. Location is important in terms of where the battery is installed. But now we've got all this outdoor rated robust battery that's available, which is all weather and so forth. What was the last part to get?
Battery size.
Battery,
yeah, battery sizing. So as I said, all batteries use 10 kilowatt hours in terms of battery capacity. When you're talking to your energy companies providing with the quotation, they'll always refer to a battery size, and that equals the number of units, in terms of what the battery can provide. So.
Okay, that's great. We have another question here, and I know we did touch on power outages, but what about advice for someone who wants specifically blackout protection?
Yeah, look, that's slightly different because with outages, you're only relying on the capacity of the battery that's available at that point. If you're looking at something specific for blackouts, then you need to sort of relook at what is the reserve capacity that will be available, how long is the blackout, and there needs to be some thought process around the design of the system so that you're always holding some sort of a battery reserve, for a blackout that happens. And you need to also understand how long this, like how long do you want the blackout, to be part of the design. Say, you've got critical load and it's 10 amps, for example, and you are designing this for a 5-hour blackout in the worst case scenario. So you need to talk to your the company that you sort of discussing the battery solution and share the detail in terms of coming up with a UPS kind of setup where that is catered for.
I have heard of an emergency circuit where you might have your microwave, Wi-Fi, and fridge, for instance, all on a particular circuit that sort of kicks in the event of a blackout. Have you ever?
Yeah, I mean, like, look, it is very similar. So basically, with the battery setup, you connect to your existing circuits and provide auxiliary supply from your battery in case of power failure. At the same time, sometimes, let's say if there is a medical machine that's in a household and you need critical power for that always, for a number of hours or something, that you need to ensure that there's reserve capacity in the battery. If the power failure happens, say at 10 p.m. at night, when solar went down at 5 p.m. and you've been using your battery until 10 p.m. and by the time the blackout happens, you don't have any battery capacity to provide. So these things, you need to sort of understand what are your requirements with power failure and blackouts, and then work towards a solution.
We've got next question we got is, if I plan to import and export to the grid, I could cycle twice a day. I assume I get a 10-year life and I will need 7,000 cycles guarantee. Is that available?
You have to look at the various batteries that's available, and go through the product data sheet and also the product warranty to ascertain that information. As I said, there's batteries that has got 25,000 cycles, and then there's batteries that has got 5,000 cycles. So you need to be very clear in terms of what you're buying.
I'm going to jump over to a couple of questions about vehicles just to keep Tim on his toes. I've got two here because they seem somewhat related, so I'm going to read them out simultaneously. So does Tim mean that an exterior V2L socket will always need an adapter? And also, would that V2L aftermarket work on a Polestar 2?
So yeah, taking both of those. So the first case, an exterior V2L, it depends on what you're talking about. So if you've got one of the cars that has like I had in the picture there, it's basically something that plugs into the charge port and presents it with a standard 10 amp, 15 amp outlet, then that's going to need that adapter. Obviously, you can't use that when you're driving because you can't have that sticking out your side of your car. And a lot of cars probably won't even let you go. Most EVs won't let you do anything with the charge port is got something connected. So, but you can have the option where some cars, like I was talking about, the BYD Shark 6 has some exterior sockets in the ute bed, so that they actually have 10 or 15 amp outlets. I think they're 10 amp in the Shark 6, so you don't actually need an adapter for them. You can just plug something straight in. So that's hopefully answers that question. The second one. That's the aftermarket V2L thing. I'm pretty sure I haven't tested it and I don't know everything about it, but I'm pretty sure that will work on any car that has a CCS2 plug on it. So it doesn't actually require any support from the car manufacturers or anything. So that's something like it's a bit of a hack, I guess. It's something that the car manufacturers could potentially detect on their software and disable because they don't actually support vehicle to load. But as far as I know at this point, you can plug in that and use it on any car with a CCS2 port. As I said during my talk, it essentially tricks the car into thinking it's charging, but it's actually discharging. So it basically just connects that exterior aftermarket adapter directly to the DC pins on the battery or the car, as it does when you're DC charging the car, and it essentially just pulls power back out instead of putting it into the car. So there's no actual, and some people say there's no way that the car manufacturers can actually prevent that happening because they actually, a car can charge on any DC charging station without specific issues. So hopefully that answers the question, but it's a bit unclear at this stage, but it should work with any car. But yeah, if you buy it and it stops working down the track, then that's sort of on you, I guess.
We've got another question here, which Tim, maybe even Avinesh, you might have some comment on this. Will selling energy back to the grid likely be taxed? I would be surprised. Conspiracy hat on, governments control when people are struggling and depending on them. Also, they want to protect the fossil fuel energy market. It's quite a political question from Stephen Do, I think.
Yeah, do you want to go first, Avinesh, or do you want me to
I'll give you the chance, Tim.
Yeah, it's a good question, Stephen. I think Stephen who asked that. I presume the answer is yes. Like I have a friend who's a lawyer, and she had that was her first question as well. Like, aren't you going to be taxed for all that income you earn from your solar and battery? And you probably will be, I guess, but I'm not sure how. I guess you'd have to declare that on your tax on your income, just like you do any other income, presumably. Good question. If there's a lawyer out there, feel free to post the answer in the chat for us if you know the answer.
Got another question here. If you have lots of solar panels, that is lots of excess solar, what is the rate it can output at, and is it possible to charge both home battery and vehicle at the same time?
Yeah, I'll just take the first part of it. You've got lots of solar on the roof. The battery system has got its own hybrid inverter, which is for charging and discharging. Say 5 or 10 kilowatt, and that limits the amount of energy that can sort of come in and go out. So that's the limiting factor. So during the day, if you've got a 20 kilowatt system on the roof, and you're producing 20 kilowatts at midday and nothing is used by the load, your hybrid inverter that's part of the battery is only 10 kilowatts, then you're only sort of taking 10 kilowatts in. The other 10 kilowatts is going off as solar export. So that's the limiting factor from a battery point of view.
Yeah, I might just add to that as well. So I think, you might have mentioned it in your presentation too, Avinesh, but there's a lot more battery systems coming out now that are DC coupled. So where the panels are DC coupled into the battery, so the panels could be charging the battery directly without doing the AC to DC and DC to AC, without doing a conversion. So they're more efficient, and potentially that means you can charge the battery and do other stuff a bit more capable, I guess.
We've got another question here. Are there any other BIDI charges in Australia at the moment? How much do they cost? When are we likely to see the national electricity rules change so that vehicle to grid is possible? I think it's already possible in South Australia.
Yeah, I can definitely answer that one. So any other vehicle to grid charges, there's as far as I know, currently the only one that's approved is the SIG Energy product, but there's a number of other products coming very soon. Off the top of my head, there's one by Red Earth, which makes battery systems as well. They've got basically there's a company which does bidirectional charging equipment in Europe called Ambibox. And Red Earth has basically taken one of their boxes and sort of rebranded it and packaged it inside a Red Earth system. So that's another one that's coming. They were at Everything Electric earlier this year, and I had a good chat with the bloke there. That's going to potentially cost around $10,000, just to give you an idea. So it's quite expensive, like the Wallbox Quasar 2 was that I mentioned earlier. But the cost is going to come down. He said there's not actually that much equipment in the box. It's just that it's an early adopter price. So potentially over the next couple of years, that'll potentially halve or get even cheaper in price. And there's other products and stuff out there coming too. I just can't remember off the top of my head right now some of the other brands, but there's definitely more coming. There might have been some other parts of that question, but yeah, the rules have been updated in terms of the regulations. We just need to basically have all the manufacturers come out and be CEC approved, the DNSPs to come out and allow them to connect to the grid and export power, and the vehicle manufacturers and equipment manufacturers of the chargers to come out and sell the products and have them all approved and work together. So it's quite a complex picture, but yeah, we're getting there. So.
Will the performance of a home battery be impacted much if it is located, say, 50 meters from the house where most energy is required?
Definitely. I mean, like if there's a distance between the battery and where the load is, obviously you sort of face some losses. One can say, we can minimize losses through thicker cables, which will add cost. From a functionality point of view, obviously there is an effect. So, there's always something to lose when you are sort of further away from the point of connection.
I see. I'll jump in there. I think it's from earlier, but maybe Brendan was asking what DNSPs are, but they're distribution network service providers, or basically the companies that run the poles and wires in the street. So if people aren't aware of what that is, that's what it is.
For example, Ausgrid or Endeavour in Sydney.
Correct. Yeah. So yeah, I think the first one that approved the Ford F-150 Lightning and SICK Energy was the one in Queensland, I think it was. I don't know if you know the Queensland one, Avinesh. But
Energix and
Energix, yeah. So there's a couple of the New South Wales ones that have also approved it since then. So.
This is a question for Tim. Can you explain the nature and scale of hardware and/or software changes to enable existing EVs to become bidirectional, AC and DC capable? Will most existing models be convertible? Right now, many people are delaying EV purchases until they are sure about this.
Yeah, great question. So I think the answer depends on what sort of, if you talk about AC or DC. If you talk about DC, it's kind of similar to what I was talking about with that aftermarket vehicle to load adapter. The manufacturers of things like the Red Earth people that have come out and SICK Energy that have got that product already. Those companies are essentially saying, look, we've tested all these cars, and they're testing ones like the Polestar 2, which has been mentioned by other people in the questions, the Tesla cars, which don't support officially vehicle to grid. They've tested all those cars and they're working fine using those batteries and vehicle to grid systems. So in those cases, if you talk about DC, there's actually no change to be made to the cars at all. Any car you've got should continue to work. And as I said, some people say, what happens if the car manufacturer detects that vehicle to grid that's not authorized and stops it from working? It's potentially a risk, but as I said, I used to think about that as well. But then someone pointed out that no one's going to stop your car from charging on a different DC charging station. So it's a similar sort of situation. As long as you can keep DC charging it, you should be able to keep DC discharging it. In terms of using AC, then that's potentially a hardware requirement of the car. So as I said before, it uses the onboard charger to send power back out that's AC already. So in those cases, most cars are not going to be able to support that and most manufacturers aren't going to go and retrofit stuff. It's just not something they're going to do. So in those cases, you potentially want to either look at a car that's already, the manufacturer says it's a vehicle to grid capable, which, like I said, a lot of manufacturers have come out and said that about their cars. Say, for example, a few off the top of my head, Kia with the EV9, they've said that. Polestar 3, Polestar's come out and said that's vehicle to grid capable. But both of those have not actually come out and said it's officially supported yet. So, yeah. But if you're talking about DC, then yeah, keep an eye on those manufacturers like Red Earth and SICK Energy and just speak to them and see what they say. But yeah, basically those cars, a lot of cars have been tested by them and working fine. So no changes on the car end required. Hopefully that answers the question.
I've just had someone asking about when the next webinar is. I just want to remind everybody that this is being recorded and we'll be uploading it to the Renew YouTube channel at some point in the next couple of weeks, hopefully. But then I've got a quick question here. How can we find out how many cycles my battery has done?
Oh, that's a pretty hard question, but I think you need to get in touch with the battery manufacturer. That's the starting point. A electrician won't be able to sort of tell you that. They can be tests done on the battery to sort of validate that.
You mentioned before software that you can get to accompany your installation. Would that potentially be an opportunity to see how many cycles?
No, because what essentially number of cycles is the usage of the battery, and there's some inner data that needs to be taken into account. So a lot of times manufacturers are involved with the process.
Yeah, hopefully that's something that comes out more, because actually I just found recently on my phone, you can actually go into the settings and look at how many cycles the battery phone has done. Phone battery has done. So in my case, it was like 27,
Yeah.
which I've had my phone for a few months. So
Yeah, if it's tied to guarantees, you'd think there'd have to be some metric that'll measure its performance. So
yeah. There's one thing that popped up on the questions before there about commenting about Avinesh and I potentially saying different things about battery sizing. So I'm hoping we can get to that.
Now's a good time, because we're starting to get into our wind-up time.
Do you want to read that question, Stephen, if you've got it there, or if you've seen that one, just so other people
I
can
did see it.
Oh, I can find it and read it. It was let's have a look. Yeah, I'll read it. It's from Brendan. He says, it seems to me that Avinesh is implying that we ought to aim for quite large home batteries, whereas Tim is implying that we should aim to rely on the battery on wheels. So in that case, I just want to clarify, I'm not saying that you should just use the car battery or go for a small home battery and rely on your car battery. I think it really depends on what your aims are and what you want to do. I personally, I'm in the market and looking for a home battery at the moment, and I'm leaning towards just going for a big home battery myself, actually, because as I said, the stuff on vehicle to grid is very new, and it's a bit of a grey area, and it's a very emerging technology, whereas the home battery stuff is just, there's a lot of stuff out there. There's brands that have been around for years, and there's a lot of choice, as Avinesh said. So I think it's not, there's not necessarily one recommendation. It's going to be up to each individual household and what they want to do. So I don't know if you want to add anything, Avinesh.
Yeah, same. I mean, like there's a lot of noise in the market. There's a lot of products available. Everyone is saying that they've got the best solution. So all I'm doing is sharing information in terms of key question that you need to ask, to understand what's best for you. So
I think we might move into wind-up mode. Stephen, did you have anything you wanted to say before I close the meeting?
No, I'm very impressed by all the talk and many of the questions. So we've run well over time. So
it's been a great level of engagement. So I want to thank Tim and Avinesh. You guys have put on a great show today, and I hope everybody found it very informative. We really appreciate everyone joining us. And like I said a little bit before, the recording of the webinar will be added to the YouTube channel in the coming week or so. And don't forget, if you're interested in becoming more involved with Renew, please visit us at www.renew.org.au. Thanks, everyone, and have a great night.
thank you.
thank you.